Why are we here? This question is as old as humanity itself. Every culture, every civilization, every great thinker, from the ancient philosophers to the scientists of today, has wrestled with it. Are we here by chance, or is there a deeper reason? The universe is vast, incomprehensibly vast. It stretches over 93 billion light-years across. It holds 200 billion trillion stars and trillions of planets. And yet, in all this cosmic immensity, we only know of one place where conscious beings look up and ask this question. Here, on Earth, at this very moment. Science has uncovered incredible truths. We now understand how galaxies form, how stars are born, how life evolves. But no equation, no theory, no experiment has yet answered the deepest mystery of all. Why is there something instead of nothing? To find the answer, we must go back, before life, before Earth, before even the first star flickered into existence, to the moment when everything, space, time and matter, was born out of absolute nothingness. Close your eyes for a moment and try to imagine nothing. No stars, no planets, no galaxies, no space to move in, no time to pass, no matter, no light, no energy. Just nothing. And yet, out of this absolute emptiness, something happened. A moment so sudden, so powerful, that it defies all human understanding. In an instant, the universe was born. Scientists call this event the Big Bang, the single most important moment in all of cosmic history. It wasn't an explosion in space because there was no space yet. Instead, it was the very birth of space, time and matter itself. In a fraction of a second, a universe smaller than an atom expanded faster than the speed of light, unleashing all the energy that would one day form everything we see today and everything we are. But here's the real mystery. Why did it happen at all? For anything to exist, there must be a cause. If you see a tree, you know it grew from a seed. If you see a river, you know it was carved by time and water. But what about existence itself? What was the seed of the universe? What force sets everything into motion? One of the most famous physicists of our time, Stephen Hawking, once said, "The universe can and will create itself from nothing. But how can something come from nothing? If there was no space, no time, no matter, where did everything come from?" The answer lies in one of the strangest and most mind-bending ideas in modern physics. Could empty space itself hold the secret to creation? If something can't come from nothing, then how did the universe begin? For centuries, this question haunted philosophers and scientists alike. It seemed impossible, until modern physics uncovered something astonishing. Nothing isn't truly nothing. In the deepest void, beyond what we can see, beyond what we can even imagine, space itself is not truly empty. It is restless. It is alive. It is filled with invisible, fleeting bursts of energy known as quantum fluctuations, tiny, unpredictable pulses of existence flickering in and out of reality. Imagine a perfectly still ocean. At first glance, the surface seems calm, but look closer, and you'll see tiny ripples, waves appearing and disappearing unpredictably. This is what happens at the quantum level, but instead of water, it's the fabric of reality itself that ripples with energy. Some physicists believe that one of these fluctuations, one of these tiny momentary bursts of energy, didn't vanish like the others. Instead, it expanded wildly, uncontrollably, and in an instant it became everything. The idea is simple yet profound. The universe wasn't created by some outside force. It bubbled into existence from the very nature of reality itself. Some scientists call this the quantum birth of the universe. It's a theory that rewrites our understanding of creation. It means that the universe didn't come from nothing, because true nothingness may not even exist. But if the universe emerged randomly from a quantum event, why does it seem so perfectly structured for life? Why is everything so precise, so balanced, so fine-tuned? Could the laws of the universe be more than just chance? Imagine you walk into a dark room and find a massive control panel stretching out in front of you. Hundreds of dials, each set to a very specific number. One dial controls the strength of gravity, another the speed of light, another the force that holds atoms together. Now imagine that if any of these dials were turned even slightly, the universe as we know it would collapse. Stars wouldn't form. Atoms wouldn't bond. Life, any life, would be impossible. But the incredible thing is every single one of these settings is exactly right for us to exist. The force of gravity is precisely tuned to 1 part in 1060, a 1 followed by 60 zeros. If it were even slightly weaker, galaxies and planets would never have formed. If stronger, stars would have collapsed into black holes. The nuclear force inside atoms is fine-tuned to 1 part in 1037. If it were weaker, hydrogen, the most basic element, wouldn't exist. No water, no stars, no life. The dark energy that drives cosmic expansion is tuned to an unimaginable 1 in 10120. If it were slightly stronger, the universe would have expanded too fast for galaxies to form. If weaker, it would have collapsed back in on itself. These are not small coincidences. These are precise, razor-thin margins between a lifeless void and a universe teeming with stars, planets, and us. So what does this mean? There are only 3 possibilities, and either this is all just a lucky accident, an outcome so improbable it might as well be impossible. There is an underlying reason why the universe had to be this way, perhaps an undiscovered law of physics. Or the universe was deliberately structured this way. But if this is just an accident, if the universe is just one random roll of the cosmic dice, could there be other universes? Universes where the dials are set differently? Universes where life never had a chance? Could we be just one of an infinite number of universes? What if I told you this might not be the only universe? What if beyond the limits of what we can see, beyond the edge of our cosmic horizon, there were countless other universes, each with their own laws of physics, their own stars, their own possibilities? It might sound like science fiction, but some of the theories in physics suggest that our universe could be just one of many, part of something far greater, a multiverse. We already know just how impossibly precise our universe is. The strength of gravity, the charge of an electron, the rate of cosmic expansion, every one of these factors is perfectly balanced to allow stars, planets, and life to exist. But if these values were random, if they could have been set to anything, then why did they end up just right for life? If you roll a trillion-sided die, you don't expect to land on the one number that allows life to exist. And yet, here we are. So scientists have asked a radical question. What if this wasn't a one-time roll of the dice? What if the cosmic dice have been rolled an infinite number of times? If there are billions, trillions, or even an infinite number of universes, then maybe we just happen to live in the one where everything worked out. But is this just an idea, or is there science behind it? Believe it or not, multiple branches of physics suggest that the multiverse might be real. Here are some of the leading theories. The eternal inflation model. Our universe is just one bubble. The early universe expanded at an unimaginable speed, a process called cosmic inflation. Some theories suggest inflation never truly stopped. Instead, it continues infinitely in different regions of space. Each of these regions could form a new universe with its own physical laws. If true, then we live inside just one bubble universe, surrounded by an infinite cosmic foam of other universes. Imagine a pot of boiling water. Each bubble that rises to the surface is like a separate universe, forming and expanding on its own. This could be our reality. The quantum many-worlds interpretation. Every choice creates a new universe. In quantum mechanics, particles exist in multiple states at once until they are observed. The many-worlds interpretation suggests that every possible outcome of an event actually happens, but in separate universes. Every decision you make, every path you don't take, could exist in a parallel reality. Did you choose coffee or tea this morning? According to this theory, you chose both. One version of you is drinking coffee, another is drinking tea, and another never got out of bed at all. Every possible version of reality exists somewhere. The question is, which one are we living? String theory and extra dimensions, more than 3 dimensions. String theory suggests that our universe may have more than 3 dimensions, possibly up to 11. If these extra dimensions exist, then other universes might be hidden within them, just outside our perception. Think of a 2-dimensional creature living on a piece of paper. It has no idea that a 3-dimensional world exists above it. What if we are like that? What if other universes are stacked all around us, but we simply can't see them? If the multiverse is real, it means we are not alone, not just in our galaxy, not just in our universe, but in an infinite sea of realities. It would mean that somewhere out there could be another Earth, another version of you, another universe where life evolved in ways we can't even imagine. But here's the biggest question. If there are infinite universes, each with different laws of physics, why does ours seem so perfectly tuned for life? Could life itself be more than just a random consequence of physics? Out of the trillions of planets scattered across the universe, one small blue world harbors something we have not yet found anywhere else: life. But why Earth? What makes our planet so uniquely suited for life to thrive? Scientists believe the answer lies in something called the Goldilocks zone, a narrow region around a star where conditions are just right for life as we know it. Not too hot, not too cold, but just perfect. Think of a cup of coffee. If it's too hot, you burn your tongue. Too cold, and it loses its flavor. But in that perfect temperature range, it's exactly what you need. Now apply that idea to planets. If a planet orbits its star too closely, the heat will evaporate its oceans, turning it into a scorching wasteland like Venus. If it's too far, the cold will freeze any water solid, making life nearly impossible, like Mars. But in between these extremes, there is a perfect zone where liquid water can exist, and water is the foundation of all known life. Earth orbits 93 million miles, around 150 million kilometers, from the Sun, placing it in the habitable zone. If Earth were just 5% closer to the Sun, our oceans would boil away. If Earth were just 5% farther, the planet would be locked in an ice age, possibly forever. A few million miles, a tiny fraction of the vast cosmos. That's all that separates Earth from being a lifeless rock or a burning inferno. Why is water so important? because it's the perfect molecule for life. Water dissolves nutrients, carries oxygen, and acts as a medium for chemical reactions. Without it, cells cannot function, DNA cannot form, and life as we know it is impossible. And yet, in the entire solar system, Earth is the only planet where liquid water flows freely. Mars may have once had water, but today it is dry and frozen. Venus is hot enough to melt lead, its water long evaporated. Only Earth has vast oceans, rivers and lakes, all crucial for life to exist. But water alone isn't enough. A planet also needs the right atmosphere to trap heat, protect from radiation and create a stable climate. And once again, Earth has exactly what's needed. Earth's atmosphere is another stroke of cosmic luck. It's thick enough to trap warmth, but not so thick that it becomes toxic. Compare it to our neighbours. Venus has an atmosphere 100 times thicker than Earth's, creating a runaway greenhouse effect that has turned it into a hellscape. Mars, on the other hand, lost most of its atmosphere long ago, leaving it cold and barren. Earth's atmosphere is 78% nitrogen, 21% oxygen, and 1% other gases, the perfect mix for breathing. The ozone layer shields us from harmful ultraviolet radiation. Earth's magnetic field, generated by its molten iron core, protects us from deadly solar winds that would strip away our atmosphere. It's almost as if Earth was designed to be a cradle for life. But was it really just a chance? There's another factor that makes Earth special, one we don't often think about: the moon. The moon doesn't just light up the night sky. It stabilizes Earth's tilt, preventing extreme climate shifts. Without it, Earth's seasons would be unpredictable, possibly making advanced life impossible. The moon keeps Earth's axial tilt stable at 23.5 degrees, maintaining a predictable climate. Without this stability, Earth's tilt could change dramatically, causing extreme ice ages or boiling summers. But that's not all. Earth has another hidden advantage: plate tectonics. Our planet's surface isn't fixed. It's broken into plates that move and shift over time. This process recycles carbon, regulates the atmosphere, and prevents Earth from becoming a frozen, lifeless rock. Plate tectonics help regulate CO2 levels, preventing a runaway greenhouse effect. Continental drift helps refresh ecosystems and maintain biodiversity. No other planet in our solar system has active plate tectonics like Earth. A stable orbit, a perfect atmosphere, flowing water, and a protective moon, moving continents. All these factors had to align just right for Earth to support life. But if Earth is so perfect, why haven't we found another planet like it? For centuries we believed Earth was the center of the universe. Then we realized we were just one planet orbiting an average star in an average galaxy. And yet, despite our cosmic humility, Earth remains special. But here's the big question. If life formed here, could it have formed elsewhere? Is there another Earth out there? The answer is more complicated than you might think. Our galaxy, the Milky Way, contains at least 100 billion planets. The observable universe? At least trillions. With so many planets, it seems inevitable that at least one of them should be just like Earth. Right? Since 1992, astronomers have discovered over 5,000 exoplanets, planets orbiting other stars. About 50 of these are in the habitable zone, meaning they could have liquid water. The closest potentially habitable exoplanet, Proxima Centauri b, is 4.2 light-years away, but we still don't know if it has the right conditions for life. So far we've found planets that are too hot, too cold, too big, too small, or too toxic for life. We have yet to find one with Earth's perfect balance. Finding a planet in the Goldilocks zone is just the first step. To truly be like Earth, a planet needs so much more. The 5 essential ingredients for a life-bearing planet are: liquid water, essential for all known life; a stable atmosphere, to regulate temperature and protect from radiation; a magnetic field, to shield against deadly solar winds; long-term stable orbit, to avoid extreme climate shifts; the right chemical elements: carbon, hydrogen, oxygen, nitrogen and phosphorus. Even if a planet checks all these boxes, there's another problem: time. Earth has been around for 4.5 billion years, but complex life only appeared in the last 600 million years. Civilizations like ours? They've existed for less than 0.0001% of Earth's history. What if life on other planets never gets the chance to evolve before something wipes it out? In 1950, physicist Enrico Fermi asked a simple but powerful question. If the universe is full of planets, where is all the intelligent life? This is known as the Fermi paradox, the contradiction between the high probability of alien life and the complete lack of evidence for it. Possible explanations are: we are truly rare. Life is far more difficult to create than we think. Intelligent civilizations self-destruct. Advanced species may wipe themselves out before spreading across the stars. The universe is too vast. Even if alien civilizations exist, they may be too far apart to communicate. Their hiding advanced civilizations could be avoiding us or watching us without revealing themselves. If life is common, it should be everywhere. But if it's rare, it means we are something truly special. If Earth is one of a kind, then it means we are living in a miracle of physics, chemistry and time. Earth has survived 5 mass extinctions, any of which could have erased life completely. Its climate, atmosphere and ecosystem have remained stable for billions of years against the odds. No other known planet has an environment as stable, nurturing and rich in resources as Earth. Maybe Earth isn't just another planet. Maybe it's a cosmic masterpiece, one that took billions of years to shape, refine and balance just right. But if life is so rare, how did it emerge at all? For billions of years, Earth was just a world of rock and water, lifeless, silent and empty. Then somehow, something changed. From a planet filled with nothing but simple molecules, life emerged. It didn't happen overnight. It wasn't the work of a single moment, but rather a process so slow, so delicate, that it took millions of years. Yet, in the end, lifeless chemicals transformed into something astonishing. Cells that could grow, reproduce and evolve. This is one of the greatest mysteries in science. How did non-living matter suddenly become alive? To understand how life began, we need to go back, way back, to the Earth of 4 billion years ago. It was nothing like the world we know today. There were no plants, no animals, no breathable air. Instead, Earth was a violent, chaotic world, a planet covered in volcanic eruptions, lightning storms and boiling oceans. But despite its harshness, something about early Earth made it different from the Moon, Venus or Mars. It had the perfect ingredients for life to begin. Earth had liquid water, the key ingredient for all life. It had an atmosphere rich in methane, ammonia, hydrogen and carbon dioxide, essential building blocks of life. Powerful lightning storms and volcanic heat may have triggered chemical reactions that formed the first organic molecules. The stage was set. But how did simple molecules become something alive? The answer begins with something small, smaller than a cell, smaller than DNA. It begins with simple organic molecules. In 1953, 2 scientists, Stanley Miller and Harold Urey designed an experiment to recreate the conditions of early Earth. They filled a sealed chamber with gases thought to be in Earth's ancient atmosphere, then sent electric sparks through it, mimicking lightning storms. The Miller-Urey experiment successfully produced amino acids, the building blocks of proteins. This was the first proof that life's essential molecules could form naturally from simple chemicals. This was groundbreaking. It meant that the basic ingredients for life didn't need a miracle to appear. They could emerge from the natural laws of chemistry. But amino acids alone don't make life. They're like letters without words, bricks without buildings. The next step was to organize them into something far more complex. To be truly alive, something must be able to copy itself. Without reproduction, life would appear once and then vanish forever. Scientists believe that before DNA, the molecule that carries genetic instructions today, there was something simpler: RNA. RNA, or ribonucleic acid, is a molecule that can store information and catalyze chemical reactions, making it a likely candidate for the first self-replicating system. Some RNA molecules, called ribozymes, can copy themselves without proteins, suggesting they could have been Earth's first lifelike molecules. Imagine a single molecule floating in Earth's ancient oceans that could make copies of itself. This may have been the very first step toward life. From there, evolution took over. Random changes in these molecules led to better, faster and more complex self-replicators. Over millions of years, simple molecules turned into tiny living cells, the ancestors of every plant, animal and human alive today. Was this process an accident, or was it inevitable? If the conditions were just right, would life always emerge? Or was Earth's first cell the result of a 1 in a trillion stroke of luck? And if it happened here, could it have happened elsewhere? Could life be waiting beneath the oceans of distant planets, just as it once did on early Earth? We now know that the basic building blocks of life, amino acids, nucleotides, and simple organic molecules, can form naturally. We've seen them appear in laboratory experiments, in deep space, even on meteorites that have crashed into Earth. But here's the problem. Amino acids are not life. RNA is not life. Even a collection of complex molecules floating in ancient oceans is not life. So what was the missing step? How did lifeless chemistry suddenly take the leap into the first true living cell? Imagine holding a single grain of sand in your hand. It is simple, unchanging. Now imagine a tiny bacterium, something smaller than a single grain of sand yet alive. It can grow, adapt, respond to its environment, and most importantly, it can make copies of itself. The leap from lifeless molecules to a self-replicating, evolving organism is one of the greatest unsolved mysteries in science. We call this transformation abiogenesis, the moment when non-living matter becomes living cells. The oldest confirmed microfossils are 3.5 billion years old, meaning life had to form sometime before that. Some theories suggest life could have begun in as little as 100 million years, an instant on geological timescales. But despite decades of research, scientists have never been able to recreate this transition in a lab. We can build all the individual pieces of life, but we still don't know how to bring them together. The smallest unit of life is the cell, a microscopic self-sustaining system that can metabolize energy, grow, and reproduce. But even the simplest known cells today are incredibly complex. Inside every living cell, thousands of tiny molecular machines are hard at work. The key features of the first living cells are a protective membrane that separates itself from the chaotic outside world, a metabolism to convert energy from the environment, a self-replicating genetic code to pass information to future generations. So, how did nature assemble these parts into the first living system? We don't fully know. Some theories suggest the first protocells formed in deep-sea hydrothermal vents, cracks in the ocean floor that spew hot, mineral-rich water. Others believe life began in shallow, warm ponds where sunlight and chemistry combined to spark the first self-replicating molecules. Hydrothermal vents contain the right chemicals and energy to drive complex reactions. Some fatty acids naturally form membranes that could have trapped molecules inside, forming a primitive cell. RNA molecules have been shown to self-replicate under certain conditions, supporting the RNA world hypothesis. But none of these theories fully explain how dead matter suddenly started evolving, growing, and competing for survival. Scientists have pieced together much of the puzzle, but there is still a gap, a missing bridge between chemistry and biology. There are three unsolved questions. How did the first cells form membranes to contain life's reaction? How did simple molecules organize into self-sustaining, evolving systems? Why did life begin so quickly, in just a few 100 million years instead of billions? Some believe life was inevitable given the right conditions. Others argue that abiogenesis may be so rare, so unlikely, that Earth could be one of the only places it has ever happened. And if we still can't recreate this process, even with all our knowledge, what does that mean for the search for life elsewhere? Is life a cosmic accident or an unavoidable outcome of the universe itself? So far, we've traced the origins of the universe, the formation of planets, and the birth of life itself. But now we have arrived at the strangest and most mysterious phenomenon of all: consciousness. Because in the vast emptiness of space, among countless stars and lifeless planets, something extraordinary happened. Matter began to think. Somehow a collection of atoms, forged inside ancient stars, arranged themselves into something that could dream, feel and wonder about its own existence. But the mysterious part is, how? At the heart of this mystery is the most complex object in the known universe, the human brain. The brain contains 86 billion neurons, each forming thousands of connections. A single human brain has more connections than there are stars in the Milky Way. Every thought, every memory, every dream you've ever had is the result of tiny electrical signals racing across this vast neural network. But the thing is, our brains are made of the same basic ingredients as everything else: atoms, molecules and cells. So why aren't rocks, rivers or clouds conscious? What makes a brain different? Scientists can explain how a heart beats. We can measure how lungs take in oxygen. We can even map the way neurons fire inside the brain. But there's one thing we still don't understand. Why does any of this create experience? We know that when light hits the eye, electrical signals travel to the brain. We know which areas of the brain process sound, touch, and emotions. But why do these signals feel like anything? Think about it. When you see the color red, your brain reacts in a specific way. But why does red feel red? Why do emotions feel like anything at all? Why aren't we just mindless machines reacting to stimuli? Some scientists argue that consciousness is just an illusion, a byproduct of the brain's complexity. Others believe it is something fundamental, as real as space and time itself. And here's where things get even stranger. For centuries, humans believed the Earth was at the center of the universe. Then we discovered that we are just a tiny planet orbiting an average star in an ordinary galaxy. Now, some scientists wonder, what if our understanding of consciousness is just as limited? Materialism suggests that the brain generates consciousness, likening it to a computer running software. Panpsychism, on the other hand, posits that consciousness is a fundamental part of the universe, akin to forces like gravity or time. Quantum consciousness adds a fascinating layer by proposing that consciousness could be tied to the mysterious world of quantum mechanics. Could it be that consciousness isn't just inside our heads, but woven into the very fabric of reality? Carl Sagan once said, "We are a way for the cosmos to know itself." Think about this. For 13.8 billion years, the universe existed without thought. Just stars, galaxies, and dust. But then something happened. The universe evolved a mind, not through magic, but through billions of years of evolution. Atoms formed molecules, molecules formed cells. Cells formed creatures that could move, react, and survive. And eventually, those creatures became us. So here's the ultimate question. Is consciousness just a rare accident of evolution, or could it be something far greater? Could the universe itself be conscious? Right now, as you listen to my voice, you're experiencing something extraordinary. Something no scientist, no philosopher, no artificial intelligence has been able to fully explain. You are not just hearing sounds. You are not just processing words. You are aware of them. But what is this thing we call consciousness? Is it just an illusion created by the brain? Or could it be something deeper? Something fundamental to the universe itself? To answer that, we need to explore two very different ideas. The first says consciousness is nothing more than an accident of biology. The second says consciousness is the very foundation of reality. For many scientists, the answer is simple. The brain is a machine. Nothing more, nothing less. According to this view, consciousness is not real in the way we think it is. It's just the brain's way of interpreting information, a useful trick for survival. Every thought, emotion, and decision you make is controlled by neurons, tiny cells firing electrical signals. The brain is like a biological computer, processing inputs and producing outputs. The feeling of being you, that's just a side effect of this complex computation. If this is true, then your sense of self, your thoughts, emotions, memories, are nothing but chemical reactions. You are, in a way, just a biological machine running a program. But if consciousness is just an illusion, why does it feel so real? Imagine a world where there are creatures exactly like us, humans who talk, laugh, cry, and react just like we do, but they have no inner experience, and they don't actually feel joy. They don't actually see colors. They act as if they do, but inside there is nothing. No awareness, no self, no consciousness. These hypothetical beings are called philosophical zombies. And here's the problem. If the brain is just a machine, why aren't we zombies? Why do we experience life rather than just react to it? Philosopher David Chalmers calls this the hard problem of consciousness. Easy problems is that science can explain how neurons process information. But hard problem is that science cannot explain why we have subjective experiences at all. This is what makes consciousness so mysterious. A computer can recognize faces. It can answer questions. It can even mimic human speech. But it doesn't experience anything. It has no inner world. So what if consciousness isn't an illusion? What if it's something much more fundamental? Now let's explore something radical. What if we have it backwards? What if consciousness isn't created by the brain, but instead the brain is simply tapping into something that already exists? This idea is known as panpsychism. It suggests that consciousness is not unique to humans. It's not even unique to life. Instead, it is a fundamental property of the universe, like gravity or time. Some physicists believe even atoms may have a tiny form of consciousness. Consciousness may not emerge from complexity. It may have always been present, even in the simplest forms of matter. The brain doesn't create consciousness, it filters it like a radio picking up a signal. If this is true, then consciousness didn't begin with humans. It didn't even begin with life. It has always been here, woven into the very fabric of reality. Here's where things get even stranger. Some scientists believe that the mystery of consciousness may be connected to one of the most puzzling aspects of physics, quantum mechanics. In the quantum world, particles behave in ways that seem impossible. They can be in multiple places at once. They can choose when to change states. And most bizarrely, they seem to react when they are observed. The double-slit experiment shows that particles behave differently when they are being watched. Some physicists, including Roger Penrose, have suggested that consciousness and quantum mechanics may be linked. Could this mean that consciousness plays a role in shaping reality itself? What if the act of observing the universe is what makes it real? If consciousness is fundamental, if it is as real as space, time and gravity, then we must ask a shocking question. Are we simply observing the universe, or are we creating it? Could it be that the universe doesn't just contain consciousness, but does it exist because of it? Is the universe alive in some way we don't yet understand? For most of human history, we believed that we were at the center of everything, that the stars and planets revolved around us, that the universe existed for us. But as we've explored the cosmos, we've learned something extraordinary. We are not the center of the universe, but we are part of it, in a way that is far deeper, far more profound than we ever imagined. Because somehow, across billions of years, the universe became self-aware. It started as nothing more than a sea of energy and particles. Then, over time, those particles formed atoms. Those atoms formed stars, and those stars forged the elements that would one day become us. Carl Sagan once said, "We are a way for the cosmos to know itself." But what does that really mean? Could it be that the universe doesn't just contain life and consciousness, but does it need them in order to exist meaningfully? Every atom in your body, every particle that makes up your hands, your heart, your brain, was born in the heart of an ancient star. Long before Earth even existed, stars were forging the heavy elements that would one day become planets and life. 98% of the human body is made of elements like carbon, oxygen, nitrogen and iron, all created inside stars. When massive stars explode as supernovae, they scatter these elements across space, eventually forming new solar systems. Every living thing on Earth is literally made of stardust. You are not separate from the universe. You are not an observer standing outside of it. You are made of it. For billions of years, the universe existed without thought. Just endless stars, silent galaxies and lifeless matter. But then something changed. Life emerged. And with life came awareness. But here's the real mystery. Is consciousness just an accident of evolution? Or could it be the next stage in the universe's journey. Life evolved from simple molecules to self-replicating cells over billions of years. Over time, these simple life forms developed nervous systems, senses, and eventually self-awareness. The human brain, arguably the most complex structure in the universe, now has the ability to reflect on its own existence. Could this be what the universe has been moving toward all along? Could the emergence of intelligence, thought, and self-awareness be as inevitable as the formation of stars? If the universe began as a mindless explosion of energy, why did it lead to something as complex as human thought? Why does the universe now contain beings that question its own existence? Perhaps this isn't just a coincidence. Perhaps consciousness is not separate from the cosmos, it is an extension of it. Some scientists propose that consciousness is an emergent property of the universe, just like gravity or electromagnetism. Others believe that intelligence is the natural outcome of complex systems, meaning that the universe may produce consciousness wherever conditions allow. Some theories suggest that self-awareness is not an accident, but a fundamental part of reality itself. What if the universe isn't just a cold, indifferent machine, but something far more profound? What if through us it is experiencing itself for the first time? In every moment of curiosity, every question we ask, every mystery we solve, we are not just studying the universe here, we are the universe studying itself. The atoms in your brain were once inside ancient stars. The thoughts in your mind are powered by energy that has existed since the beginning of time. Every experience you have, every moment of wonder, love, joy, or sorrow, is an expression of the cosmos becoming aware of itself. So, when you look up at the stars and ask, "Why am I here?" perhaps the universe is asking the very same question. Through you. But if we are the universe waking up, what is our role in its story? We've explored the idea that we are not separate from the universe, that we are made of the same elements forged in ancient stars, and that through consciousness the cosmos is becoming self-aware. But what if our role in the universe is even greater than that? What if instead of just observing reality, we are helping to create it? It sounds impossible. Surely the universe exists whether we are here or not, right? And yet deep in the heart of modern physics there is a strange and unsettling mystery, one that suggests that the very act of observation might shape reality itself. Welcome to the world of quantum mechanics. At the smallest scales of existence, far smaller than atoms, smaller than even protons and neutrons, there exists a world that defies everything we think we know about reality. It is the world of quantum mechanics, and it follows rules so strange, so counterintuitive, that even Albert Einstein himself struggled to accept them. In the quantum realm, particles do not behave like solid objects. Instead, they exist in a state of superposition, meaning they can be in multiple places at once. They don't take on definite properties until they are observed. A particle is not here or there. It is both. It is everywhere and nowhere at the same time until someone looks at it. The mere act of observation forces it to decide on a single reality. But how can that be? How can simply looking at something change what it is? To truly grasp this mystery, let's examine one of the most famous and baffling experiments in the history of science, the double-slit experiment. Imagine shooting tiny particles, like electrons, at a barrier with two slits. If electrons were just tiny bullets, they would pass through one slit or the other and form two clusters on a screen behind the barrier. But that's not what happens. Instead, the electrons behave like waves, spreading out and creating an interference pattern. suggesting that each particle passes through both slits at the same time. Somehow, the electron doesn't choose a single path. It behaves as if it is in many places at once. But if you set up a detector to observe which slit the electron goes through, the wave-like behavior disappears. Instead, the electron suddenly chooses just one path, behaving like a solid particle again. In other words, when we watch, reality changes. When we don't, it behaves differently. This is not science fiction. This is real. It has been tested and confirmed countless times. For decades, physicists have struggled to understand what this experiment is really telling us. Why does the universe behave one way when we observe it and another way when we don't? Some believe that this means consciousness is playing a direct role in shaping reality. That before we observe something, it exists only as a cloud of possibilities, and that it is our observation that forces it into one definite state. The Copenhagen interpretation suggests that reality remains indeterminate and uncertain until it's observed. The many worlds theory takes a strikingly different stance, proposing that every possible outcome of any event occurs in a separate parallel universe. Meanwhile, the pilot wave theory posits that particles are always real but are guided by an unseen and dynamic wave. Could it be that reality is not something that simply exists, but something that is participatory, something that requires an observer to bring it into being? Some of the greatest minds in physics have speculated that consciousness might be more than just an observer of reality. It might be part of its very foundation. Physicist John Wheeler proposed a radical idea. We are not just passive observers, we are participants in the creation of reality. This means that the universe does not exist in a fully determined state until it is observed. In a way, reality is like an unfinished painting, one that remains vague and uncertain until a conscious mind looks at it. The quantum eraser experiment suggests that time itself might be influenced by observation. Some interpretations of quantum mechanics imply that consciousness plays a direct role in defining what is real. The biggest question: does reality exist independently of us, or do we help create it? If the universe needs observers to bring reality into focus, then does that mean life itself is necessary for the cosmos to be complete? For billions of years, the universe existed without thought. But now, through conscious beings like us, it has developed the ability to observe itself. So here's the question. If consciousness and observation shape reality, then are we just a product of the universe, or are we an essential part of its existence? Physicist Max Planck, the father of quantum mechanics, once said, "I regard consciousness as fundamental. I regard matter as derivative from consciousness." Could it be that consciousness is not something that arises from the universe, but something the universe itself is made of? And if consciousness is the foundation of reality, then what does that mean for our place in the cosmos? Through us, the universe doesn't just exist. It understands, questions, and reflects on its own nature. Perhaps the purpose of consciousness is not to observe the universe from the outside, but to participate in its unfolding story. If this is true, we are not separate from the cosmos, nor are we mere bystanders. We are creators, explorers, and narrators of the universe's vast and intricate tale. The biggest mystery may not be what the universe is, but why it exists at all. And perhaps consciousness, through its act of observing, questioning, and creating meaning, is the missing piece to that puzzle. We've explored some of the most mind-bending ideas in science. How the universe emerged from nothing, how consciousness might be woven into reality, and how observation itself could shape existence. But these ideas lead us to something even more profound. If the universe is fine-tuned for life, if consciousness plays a role in defining reality, then what does that say about our place in the cosmos? Are we simply intelligent animals navigating a meaningless universe? Or are we, through our awareness, the very thing that gives the universe meaning? Let's step away from the equations and the theories for a moment. Let's ask the bigger, deeper questions that science alone cannot answer. Some of the greatest thinkers in history have suggested that the universe is not just a collection of matter and energy, but something more, a living system, evolving not just physically but in terms of complexity and awareness. Pantheism philosophers like Spinoza and Einstein believe the universe and consciousness are one and the same. Idealism, championed by thinkers like Plato and Berkeley, proposes that reality itself may be a construct of the mind. Teilhard de Chardin's omega point theory imagines the universe evolving toward greater complexity and self-awareness, with consciousness as the ultimate end. If consciousness is not just an accident of biology, but an inevitable result of the universe's unfolding, then perhaps our purpose is not just to exist, but to witness, to question, to understand. Could the universe itself be a kind of vast, evolving intelligence, one that has been building towards something all along? But if that's true, then why do we experience suffering, uncertainty, and confusion? Why does reality often feel chaotic rather than meaningful? Not everyone agrees with the idea that consciousness is fundamental to reality. Many scientists argue that this is just anthropic bias, our tendency to see ourselves as special when we are really just a tiny part of a vast, indifferent universe. The brain creates consciousness through chemical and electrical processes, nothing more. The universe is not fine-tuned for life. Life simply adapted to whatever conditions existed. Quantum mechanics does not require a conscious observer, only interaction at the quantum level. The idea that consciousness plays a role in reality is, to some, a misinterpretation of physics. Is it possible that we are simply imposing meaning onto an indifferent universe? Could it be that consciousness is just a fleeting byproduct of evolution with no deeper significance beyond helping us survive? So where does this leave us? Are we the universe's way of knowing itself, or just highly evolved, biological machines searching for meaning where there is none? Perhaps the real truth lies somewhere in between. Perhaps meaning is not something given to us, but something we must create through discovery, through art, through love, through the pursuit of knowledge. We are a way for the cosmos to know itself, but the cosmos does not know that yet. We have only begun to wonder. So what do you think? Is consciousness fundamental to the universe, or just an illusion we tell ourselves? We've explored the birth of the universe, the fine-tuning of reality, the origins of life, and the mystery of consciousness. But now we arrive at the most personal and profound question of all. What is our purpose? Are we simply a fleeting accident of physics? Atoms and molecules arranged in a way that temporarily thinks and feels? Or is there something more? Something deeper? For billions of years, the universe existed without thought. It was nothing but stars, galaxies, and the silent dance of physics. Then, somehow, through the laws of nature, through chance or destiny, life emerged. And with life came something new, awareness. But the incredible thing is, the universe didn't just create beings that survive and reproduce. It created beings that question, explore, and wonder. We are a way for the cosmos to know itself. So, could that be our purpose? To be the eyes, the mind, the consciousness of the universe? If so, then perhaps our role is not to seek meaning out, but to create it. For thousands of years, humans have searched for answers, from ancient myths to modern science, from religion to philosophy. But what if the answer is not written in the stars? What if it is not something given to us, but something we shape ourselves? Science tells us that we are part of the universe, not separate from it. Philosophy tells us that meaning is not found, it is created. Every action, every discovery, every connection we make adds something to the universe that was not there before. Maybe our purpose is not a grand cosmic plan. Maybe it is simply this: to learn, to explore, to love, to create, to experience. And in doing so, we give the universe something it never had before, a reason to exist. The atoms in your body will one day return to the stars. The molecules that make you will one day become part of something else. But right now, in this moment, you are alive, you are conscious, you are here. And that means you have a choice: to live with curiosity, to seek knowledge, to create, to connect, to make this fleeting moment of awareness mean something. Philosopher Alan Watts once said, "You are the universe experiencing itself for a little while." So the question is no longer just, why are we here? The real question is, now that you are here, what will you do?